Hello, everybody. I'm Steve Fuller. I'm professor of social epistemology at the University of Warwick in the UK. And what I primarily study is the social foundations of knowledge, all kinds of knowledge. But of course, the most important form of knowledge in the modern period has been science. Science understood in a very broad way. So, not only the sort of fields that we normally think about as being sciences, but also the way in which science influences our imagination and the way in which we deal with things in everyday life. And of course, science fiction falls into that category. I've been giving this kind of a lecture here for the last, I guess this is the third year, and it's a very interesting challenge, you might say, to talk about the topic that I will be addressing today, the thin line between science and science fiction. Because, in fact, these two things are sort of, you might say, joined at the hip. So in other words, there's not really a clear distinction in a certain kind of way. And I'm going to explain that in the course of this lecture. And a couple of the issues that I'm going to be raising that typically have a kind of science fictional character. One issue is going to be the issue of time travel. Okay, so that is, of course, a very familiar kind of motif in science fiction. And I'm also going to be talking about the idea of extraterrestrials, especially the ones who might be visiting us. And of course, the latter has received a lot of attention lately because of the release of UFO files in the United States. This has been going on now for a couple of years throughout the entire Trump administration, basically. And it's raised a lot of interesting issues, right? But both of these issues, time travel and extraterrestrials, are issues that sort of land, you might say, on the divide between science and science fiction, because it's very hard to tell which is which, and even whether one wants to make a distinction. And I think that's the kind of question that in a sense should be left in your minds after you hear this lecture, namely the extent and the conditions under which you want to draw a distinction between science and science fiction. Okay, so let me begin. I am going to begin with the guy who is normally seen as the founder of the modern scientific method, and that guy is Francis Bacon. Francis Bacon lived in the late 16th and early 17th centuries. He was the Lord Chancellor of King James I, and King James I is a very important monarch in the history of England. He is the one who commissioned the first complete English translation of the Bible, what's called the King James Version. And Francis Bacon was basically, as the Lord Chancellor, was his personal lawyer. Okay, so he was the guy who gave the king advice in terms of doing various kinds of things. And if we're talking about the late 16th, early 17th centuries, we're talking about a period in which Britain, like a lot of Northern Europe, had broken away from the Catholic Church and were very much part of this thing called the Protestant Reformation. And this was basically trying to establish a kind of independent reading of the Bible to validate the kind of Christianity these guys were pursuing. And this also had a lot of downstream consequences, which we associate with modernity. So, for example, the idea of nation states, right, and that they're secular in some sense, right? In other words, that the kind of the sort of norms and laws are dictated by the people who rule the country, not by some kind of external religious authority. Okay, so this idea starts to actually get some traction during the Protestant Reformation. There is also the idea that one needs a kind of independent form of knowledge other than the knowledge that is being taught by the Catholic Church, right? And this is where the scientific method comes in, and Bacon is very instrumental in this. Because what Bacon argues is that most of the stuff that people have been considering knowledge, up to this point, has basically been a kind of glorified hearsay. And the hearsay, right, coming from the experts. In other words, you believe something because the experts say so, and they've been saying this for thousands of years, and so they must be right. Now, these experts, of course, that we're talking about here typically tended to be theologians, right? But also the sort of ancient classics, right? And in particular, Aristotle. Okay, and Aristotle is quite important in this context because he is a sort of guy who actually wrote a lot about the sorts of things that we now call natural science, but most of his takes on them were wrong. But nevertheless, he was writing about the nature of life and the nature of the planets and, right, the nature of matter and motion and all this kind of stuff that we normally associate with modern science. Aristotle was writing about. People believed in this stuff, but they weren't checking for themselves. Right, and this is what Francis Bacon introduces, namely that part of the independence that a country like England would have from the Church of Rome would not just be a kind of political independence, but it would be a kind of epistemic independence, right? In other words, an ability to think for yourself. And this is an idea that becomes, if we sort of fast forward from the late 16th century to the late 18th century, right, we have the Enlightenment, which is very much about thinking for yourself. Well, this begins with Francis Bacon. Now, Francis Bacon, as I said, is very much known for the scientific method. Now, what is this scientific method? Well, there are a couple of aspects to it. The one aspect, which perhaps you know about, is the one where you basically have to test your claims, right? So in other words, all these taken for granted views from Aristotle and the theologians and so forth, they've got to be tested, right? And they've got to be tested in a way where you can be able to tell as a result of the experiment, right? And Bacon was all about experiment. Right, as a result of the experiment, you could tell which one is right and which one is wrong, right? You can make a distinction between the two theories, right, as a result of the experiment. So that's how you set up an experiment. It's not just an ordinary observation. It's an observation that is being constructed to test opposing claims. One claim, let's say, being the claim of the establishment, and the other claim being a kind of new kind of claim that is coming from an independent source of evidence, right? And then you have a kind of way of kind of comparing and then deciding which one is correct. This is basically the scientific method in one sense. Now, the other aspect of the scientific method, which I think gets us in a way that's sort of relevant, I would say, to science fiction, is the idea of what is the kind of knowledge that science is supposed to provide. Okay? Now, if you look at somebody like Aristotle and you ask, okay, Aristotle, what exactly is science? What kind of knowledge is science? The general answer that he would give is inductive, what we would now call inductive generalization. So, in other words, what Aristotle would say is knowledge is the kind of knowledge that we see every day, right? That we see every day on a regular basis, right? It's inductive in the sense that if you've seen it before, you expect you'll see it again, right? Like the sun coming up every day, that kind of thing, right? And in a way, that's science for Aristotle. It's just at that level. It is the regularities that you can find in natural observation, the sort of thing that, let's say, anyone with any, kind of awareness and common sense, but doesn't have to have a lot of technical training, could figure out for themselves. Okay? And of course, a lot of the world is run this way. There's no doubt about it, okay? And one of the things that's interesting about Aristotle is that he, in a way, tried to, you might say, intellectualize and justify all of these kind of common sense views of the world that we ordinarily have about, heavy objects fall down, for example, right? Aristotle doesn't have any idea of universal gravitation, for example, and he has no idea of inertia either in the Newtonian sense, right? I mean, he just has this idea that heavy objects will fall down and they'll fall down faster than lighter objects, right? End of story, right? And that's because of the mass that's contained within them. There's nothing more going on there than that, right? And so for Bacon, this wasn't good enough, right? For Bacon, this is not the right way to think about science, right? In other words, science isn't just the stuff that you regularly encounter every day. Because, of course, if you think about it for a few minutes, right, if you think about, imagine you live in different parts of the world, And I mean, nowadays it's hard to kind of imagine what I'm talking about because, in a sense, our world has been very much globalized through telecommunications and the internet, and the fact that I'm in England talking to you in Japan, right? I mean, there's a sense in which we have become much more one world. But imagine the time of Francis Bacon. Right, so Francis Bacon, late 16th, early 17th century, right, there's not even the telegraph, right? I mean, and postal systems were very unreliable. I mean, all this stuff just happens later, right? Organized postal system is really something that does start to get seriously invented, right, really the 18th century and the 19th century, right? And the telegraph comes in the second half of the 19th century, and of course, by the time you get to the 20th century, in pretty rapid succession, you have the mass production and distribution of telephones and radio and television and all the rest. Right. So there's a kind of an acceleration that takes place in the kind of communication technologies that bring us together and make us kind of one world where it's possible, as it were, to have one kind of consciousness in a sense. But if you're going back to the late 16th, early 17th century, it's not like that at all. And in fact, it was quite common, right, for people who live in different countries, especially if they lived in different cultures. And so, even though the Catholic Church, in a sense, could kind of control the kinds of things that people thought about the world they lived in, right, and they can enforce Aristotle on people and stuff like that. If you go to China or India, right, or any of these other advanced places far away that are not influenced by Europe yet, you get a totally different idea of what inductive generalization means, right? What are the regular occurring patterns in your experience? Blah blah blah. And Bacon knew this, and Bacon said, "Look, this is not science. All we're doing is codifying our local prejudices, right? Our customs, basically, right? What Aristotle was calling science, Bacon would call customs, right? This is basically the kind of world that we have got used to living in." Right? And this is kind of how it works, right? And that's not good enough. Why? Because Bacon had this kind of interesting conception of science, which is very much part of the Protestant Reformation and what became part of the scientific revolution, which Bacon was very much in the forefront of, which does begin right in the late 16th century with people like Bacon, and of course Galileo would be his relevant contemporary, right? But really comes into its own right in the 17th century and culminates with somebody like Newton. Now, what is this alternative view of science that people like Bacon and Galileo and Newton are pushing? It's basically a view of science, you might say, from God's point of view. And this is where the science fiction stuff starts to come in. Right? So, in other words, the kind of science that we need is not simply a science that codifies our everyday experience, right? But rather, we need a science that is able to, as it were, make claims about all possible experience. All possible experience. That is to say, all the experience, not only the kinds of experiences that you're likely to have in one lifetime, but the kinds of experiences that have existed forever, right? Before you were born and after you die, right? The kinds of experiences that exist in places that you will never see, right? That's what we're talking about, right? What we call, in the modern period, universal laws of nature. Okay? That's a totally different thing, right? That these are laws that are supposed to apply equally no matter where you are in the universe. And in fact, if you ask, the range of experiences, the range of possible observations to which they apply, infinitely more than anything that any individual human or any group of humans could ever experience. And I think that is true, right? I mean, if you think about what a scientific law is supposed to be, just think about Newton's laws or Einstein's laws, right? You think about any of these laws, what are the claims made on behalf of these laws is that they apply everywhere, right? Including the places that you never experience. And in fact, most of what these laws apply to are things you don't experience. Okay? Now, that's kind of interesting, right? Because what that means then is that science, in a sense, is a kind of a intellectual vehicle for scoping out the imagination, the full imagination, right? And of course, that's why I say God's point of view. And that is certainly a phrase that somebody like Isaac Newton would use to describe what he was doing when he was coming up with his laws of nature. And of course, you see it down through the ages after Newton. You know, Einstein in particular used to invoke this a lot, even though Einstein's conception of God is rather different from Newton's conception of God. And of course, you even see people like Stephen Hawking, right, who is an atheist, doesn't believe in God, nevertheless talking about the laws of nature as getting into the mind of God, right? So this is still a very common parlance for physicists, notwithstanding the fact that a lot of these guys nowadays don't believe in God. So this is very interesting. Now Bacon begins this. Now this is, by the way, it's important to see here what the connection is between the idea that there are universal laws of nature and the ideas that there are experiments, because those two things are connected together. And this goes to kind of the way in which science fiction tends to get formulated. Because one of the things that Bacon was saying, and this is very much part of his way of thinking. It's been very controversial over the century, right? That nature does not reveal her secrets easily. And notice this is female nature, right? So nature needs to be tortured, even raped. I mean, these are terms that do get used, right? And if you're interested in that angle about the kind of the gendering, you might say, of nature, the feminization of nature, that in fact is behind a lot of the rhetoric in the scientific revolution, I recommend a book by Carolyn Merchant, came out about 1970, right? So that's a long time ago, right? Called The Death of Nature. And the point, though, that I want to stress, I don't want to stress the gender point here. What I want to stress is the fact that Bacon comes into this business with a rather, you might say, suspicious attitude toward nature. So in other words, unlike somebody like Aristotle, and I think this was also true of the Catholic Church generally, who sort of believed that nature as it normally presents itself to us is kind of the full range of things out there, right? If it existed, we would have seen it by now, kind of thing, right? That's pretty much Aristotle and the Roman Catholic Church. And in a way, it created a sort of what should we say? It created a certain kind of equilibrium with the world, right? People were able to live in this kind of world, right? Because the world was kind of as it appears, right? That there's no funny business happening behind the scenes, right? Everything is as you see it. And of course, there are exceptions every now and then. And of course, things don't, always make sense. And of course, the Catholic Church, under those circumstances, might talk about things like miracles, which in a sense gets used to reinforce its authority in the situation. Bacon is really different, right? Bacon has a suspicious attitude toward nature. And what that means is he doesn't believe that everything you see is all there is, right? There's more than meets the eye. Now, how do you then realize this? How do you find out this more that meets the eye? Then, right? What you do is you do an experiment, because what an experiment does is that it puts a phenomenon under unnatural conditions. This is why experiments tend to happen in laboratories, right? They tend to happen and what is a laboratory? A laboratory is an artificial space for inquiry, right? So in other words, you're not looking at things as they normally are in the wild, as it were. You are actually looking at them under controlled conditions, typically with some experimental apparatus techniques, could be microscopes, telescopes, right? You could be using all kinds of things, sometimes even to dissect the natural objects in various ways, right? And what this then allows you to do is to study the object under conditions that you would otherwise not have. Right? So these are the unnatural conditions. So it's often very difficult to tell the difference between two knowledge claims. People make alternative knowledge claims because all the evidence you have seems to support both of them equally. So what you need to do then is you need to create a situation in which you can tell the difference between one and the other. And that is what an experiment is. Now, what Bacon is doing when he is thinking this way and when he promotes this idea of experiment is he is thinking counterfactually. Right? And this is an important part of what a scientific law is, right? Remember, I said earlier that a scientific law doesn't just cover what you normally see, but it covers the conditions you don't see. What would happen if, right? That's a counterfactual. What would happen if this situation had been changed a certain way? What would happen if, right? Instead of things being like this, it were like that. What would follow from that? That is the proper formulation of a scientific law covering all possible conditions, in both the ones that we normally experience and the ones we don't experience. And if you think about laws in this very expansive kind of way, right, covering all possible experience, right, then you end up with a rather different view of reality, right, where most of, what's going on in reality isn't something you normally see, but in fact requires some kind of technological intervention in order for it to be manifested, right? And this, of course, is where science fiction comes in, because one of the things that you know about science fiction for sure, right, is that it typically involves inventions, right? It involves inventions. It involves kind of new techniques, new way of seeing things, like a time machine, for example, right? These things are actually quite significant to the plot line. Why? Because these turn out to be leverages for opening up realms of experience that would otherwise not be available to the ordinary observer. Okay? So in that respect, science fiction shares very much kind of the Baconian mentality that enabled the scientific method. Okay? And the only difference then is that the science fiction stuff, of course, never gets tested under proper experimental conditions, though very often in science fiction works, experimental conditions of a sort are described in quite a lot of detail. So, in other words, you kind of imagine that, in fact, it might be possible to do the kinds of things that these guys are writing about in these science fiction stories. Um, and in fact, right, if we look at something like time travel, right, time travel is a very good example of something where there's been a lot of toing and froing from the scientists to the science fiction, back and forth, right? Where the ideas about this have mutually informed each other, and there are and it's and I would say in many respects, time travel is kind of really, um, kind of the place where you could sort of see uh, the significance of science for science fiction, right? Both the way it expands and limits the imagination. Why is this? Well, one of the things that one needs to imagine, right, is so we have this world of all these possible experiences. And as I was saying, um, the way we would think about a scientific law is in terms of saying, right, if this happens, that happens. If this, and this that happens, we could talk about something hypothetically, a counterfactual situation. Were this to be the case, then this would follow. Now, underlying this line of reasoning, what's often called conditional reasoning, are certain views about causation, right? And in a sense, what all these scientific laws with their counterfactual conditions, right? If this were to be the case, then this would be the case, right? What they are addressing is the issue of causation, how one possibility alters other possibilities. Okay, and the whole idea about causation is trying to find limits on this. So, in other words, one of the things that however much the laws of science might change, right? One of the things that is true is that not everything is possible all at once, right? So in other words, there are constraints over if something happens, then something else can happen. There are constraints on these. These are causal constraints. And even when we're talking about fictional situations, right, counterfactual situations, right, those laws of causation still apply. Now, see, this is what makes the whole time travel thing very interesting, because what it does is it challenges our ideas of causation at a very fundamental level, because it forces us to think about how events in the world hang together ultimately, such that if you were to go back to the past and change something, to what extent would that change other things? And is it possible, would it be possible to actually get a targeted result? In other words, as you know, a lot of time travel stories often involve what you might say a sort of a kind of what should we say reparations, right? Try to fix something, right? You're trying to fix something in the past that went wrong. How do you stop Hitler, right, before he does anything disastrous, right? There's always that kind of very much that kind of mentality. Now, of course, if that's kind of your idea of the time travel story, namely you want to fix something that went wrong in the past because you imagine that, in fact, this thing in the past has led to a lot of bad consequences in the future, right? It only makes sense that you would do that if you think you could have a targeted result. In other words, that actually getting rid of Hitler at some point in history would have indeed led to a better world. Okay? So that is kind of a judgment that you make about causation that is being tested by going back in the past and getting rid of Hitler. And of course, if you're the sort of person who believes that Hitler is, primarily responsible for everything that's gone wrong for the last 100 years, then you're going to believe this, right? You're going to believe that just getting rid of Hitler would make the world a better place, right? And you would see the results now, right? As a sort of ripple down through history. But is this true? You see, now when we're engaged in this kind of thinking, which is that is quite recognizably a kind of science fictional way of thinking, going back in a time machine, killing Hitler before he does anything, and then looking at the consequences now. You're also wrestling with science at its most fundamental level with regard to this conception of universal laws. Because actually, if we understand the universal laws of nature, we should have an answer to this question, right? In other words, we should know even before we take the trip back to whatever 1930 or something. We should know we should be able to predict at least what kind of intervention at what point would make the kind of difference that we want, right? If we really understand the laws of nature, we should be able to do that. And so in that sense, getting the science fiction story to work out right and getting the science to work out right are pretty much the same thing, okay? And I do think this is one area where the two are really kind of working together. And when people talk about, the credibility of a lot of these time travel stories, they are often talking about the extent to which the science holds up, right? And not just the science about whether you can build a time machine, because I know there's a lot of ink spilled on that topic. Well, can you build a time machine? Could you go back? Well, the point is that once you have something like a wormhole or some way of cutting across dimensions and in space, right? You might be able to do something like this. So in a sense, that part of the story depends on, you might say, a different part of physics. But if we're talking about the plot line proper, right, where the motivation for the plot is actually to do something to have a result in the future, right? Then it's very much kind of an open, question about what the physics is likely to say about this. Now, this is a very interesting point, and it brings a couple of interesting aspects to it. One is sort of the larger way in which we do talk about time travel, because it's true that when H.G. Wells wrote this book, The Time Machine, he was pretty much going there as a tourist, right? I mean, in other words, the main character taking the time machine back into the past and then the future, right, was basically doing a kind of tour of evolution, you might say. There wasn't this kind of interventionist kind of mentality that's so strongly, strongly part of later discussions of time travel. Okay, so in that sense, the time machine idea um, is a bit naive, you might say, from the standpoint of the physics, right? And also maybe even a bit naive from the standpoint of the motivation for doing it, because you do have to think, supposing we spent a lot of money, and tried to build time machines, supposing that became some kind of a priority, why would we be doing this? Would it just be, as it were, to find out what things were like in the past, and not try to disturb them? Or would the motivation be to go back to the past and in some way alter it to bring about a better future, a better world in which we live in, right? So instead of changing something in the world now to make our world a better place, if we had the technology, why not go back to the past, right, and prevent the bad things from having have happened? And then you would automatically, you might think, then get a better future. Now, it is possible that physics could develop in such a way to allow that possibility if we understood kind of the causal workings, right, of nature, how all these counterfactuals, if this happens, then that happens, right, play out. And one might want to construct a kind of physics, right, that would enable us to do that. And so I mentioned last year, I think briefly, a television program, now I think about 20 years ago, called the 4400. Okay. And the 44, and this was this show was on for about 3 or 4 years, and then it got hit by one of the writers' strikes in Hollywood. So this is about 20 years ago now. I think the program was on CBS. You could probably find it somewhere online. The premise of this program is that people in the future who actually have quite a lot of science and have, as it were, ways of building, time machines in a sense, or at least being able to transport people in time. I don't know if they use machines. I forgot. But they could transport people back in time, and they also understand the physics, as it were, of history, to be able to pinpoint the sorts of people who need to be in the sorts of places in order to prevent what is an ongoing catastrophe at the time of the writing of this thing, right? So, in other words, these people in the future are suffering a major impending catastrophe that's going to destroy them, and their science is developed in such a way that they actually know how it was caused, you might say, right? Or at least they know enough of the conditions, and they've got enough high enough technology to be able to go back to the past, that they're going to do that instead of trying to do anything in the present, because it's already too late in the present to do anything there. Now, you can imagine, right, that we could end up living in such a world where we have this very kind of advanced science that can do all this amazing stuff, but nevertheless, we're incapable, of handling the crises before us because, in a sense, they may be too complicated. There may be too much to get our heads around because we've been acting too late on them, right? Very much like ecological crises are now, right? A lot of people talk about ecological crises, at least in that way, right? That in a sense, it's too late. We can't do anything now, right? Given where we are. Well, then you might say, but we're smart enough to go back to the past to change things. Okay, so this is what this is about. Now, of course, this becomes very tricky because there are issues about how long the interventions need to be. And of course, if these people are going back into the past, they're people, they're not so many centuries that the people are so different, right, from each other, you might say, but they are different enough. And there are going to be all these little things that can end up causing problems. And then there's the interpersonal relationships, especially if people have to be back in the past for a long time and it takes them a while to do what they're supposed to be doing. They actually have to become friendly and even become lovers of various people. And then the issue about their identities, and about that they're there for a reason. And, all of this ends up complicating the plot beyond what the people in the future had imagined would happen. So there's all this anxiety and drama going on, trying to manage this situation, you might say. And it's psychologically very sophisticated. I have to say, I do recommend this to you. But it is, in a way, it kind of highlights a kind of situation that perhaps we might end up being in at some time in the future. Now, I would make a couple of general points about this, okay? Because I want to say a little bit about extraterrestrials at the end, but I do think the time travel thing is quite interesting from the standpoint of highlighting the views about causation that we have within science. And so I want to talk about two kinds of ways we think about things. We could talk about an overdetermined world and an underdetermined world. And the way in which I want you to think about this is to imagine an intervention in the past, right? So imagine someone goes into the past. And they change something, and it's invariable, that someone will change something, even if they don't mean to change something, right? I mean, there are also a lot of science fiction stories that are like that, right? Where you're supposed to go back to the past, you're supposed to be, non-obtrusive, not do anything to disturb things, but you end up disturbing something without realizing it. And then the question becomes, does it matter, right? Now, if you believe in an overdetermined world, right? In other words, you believe you believe that there's a sense in which, and a lot of our views about reality are kind of overdetermined in this sense, right? In other words, we believe that even if a couple of things were different, even a couple of things got changed, still there is a kind of overarching arc to reality, right? That things will end up a certain way. Things will, things could have happened in many different ways, but in many respects, things will end up the same way, right? You may know in the law of thermodynamics, right? There is the entropy principle, right? Which is that order tends toward disorder in the long run. But of course, along the way, there may be many local pockets of order. But nevertheless, in the end, you get the heat death of the universe, as it was called back in the late 19th century, right? Right. So in other words, everything just falls apart. Everything just gets cold, right? And this was a kind of in the late 19th, early 20th century science fiction. This was often very much a motif, right? This is based on an overdetermined view of the world, namely where you could change things, but things will end up pretty much the same way. So let's say you get rid of Hitler, but there'll be some other dictator who comes up. Right? And that dictator will also kill 6 million people. Maybe not Jews, maybe somebody else. Right? I mean, and so that is the overdetermined view of the world. And like I say, I think, our taken for granted views of reality do kind of bake in a certain amount of overdetermination. So that's why, we sort of say, oh, it could be done this way, it could be done that way, and you still get the same outcome. The other view is the underdetermined view of the world, right? Where basically you change anything, you change everything, right? So, you make one little change and boom, you have this thing like, you've heard of this, the butterfly effect, right? Where any little change can end up having long-term cataclysmic consequences. And of course, this, if that's true, then the whole idea of making any kind of strategic intervention of the sort of, let's say, these people in the 4400 group want to, right, or a lot of the kind of time travel that is interested in reparations of some sort, right, that would be impossible, right? That would be impossible to do because you wouldn't be able to control the consequences. Things would just spiral into a kind of another world, right? And so the people who believe in this kind of undetermined kind of world, right, typically believe that it's that in a sense reality is open ended, right? Reality can go in all kinds of ways at any given time. There is no, as it were, closure, natural closure to reality, right? A lot just depends on how the events play out. And if you change some of the initial conditions, you have thereby changed the consequences in a potentially substantial way. Now, of course, part of what science is trying to do is to try to find some kind of figure out what are the actual causal rules that govern all of these connections between events, right? So, in other words, science is about managing the extremes of the overdetermined world and the underdetermined world, right? In other words, to what extent are interventions possible? I mean, I've been talking about time travel in terms of intervening right in the past to change situation in the present, which from the past standpoint is in the future, right? But of course, whenever we do any sort of intervention in the present for purposes of influencing the future from our present, we're doing pretty much the same thing, right? The reason why we think it makes sense to substantially change the world, the way in which we operate, right? To change, use new technological infrastructure, right? Introduce new energy sources, withdraw old energy sources, right? All of these very big moves that we make in the present, the reason why we do these is because we expect it will have some kind of positive effect in the future, right? So in that sense, that kind of very ordinary kind of way of doing science and technology policy for improving the human condition also depends on this kind of causal reasoning, which I'm arguing, is common not only to science, but also to science fiction. Okay. And so that's how time travel gets us very much into this kind of deep structure of how scientific reasoning works. But there's another thing I'll spend less time on. I mean, if we do this again next year, I might spend more time on this. But it's something that I'm increasingly interested in, and I just want to float an aspect of this to you. And that's the idea of extraterrestrials, because this has become, as I say, kind of a big deal in recent years. Um, and one of the main problem, and this is where, again, you get sort of the sort of thin line between science and science fiction coming up. As we see nowadays, right, the way in which we tend to enter into this discussion in the contemporary period is we talk about unidentified anomalous phenomena, right? What we used to call UFOs, right? We now call UAPs, right? You've run across this term, right? UAPs. And what does that indicate to you? Well, what that tells you is, and this has always been true with the discussion of extraterrestrials, that the first encounter, you might say, with the possibility that there might be intelligent life outside of Earth, is always has to do with ambiguous evidence, right? Ambiguous evidence, right? So we're talking about something that does not fit into anything like the inductive generalizations, let's say, that Aristotle would talk about, but they don't even enter into the kinds of things that are normally called scientific laws. At least scientific laws would not predict these things, right? And so this evidence, such as it is, right, is not clear what it's evidence for, right? And when we talk about evidence, we usually have to have some idea of what it's for, evidence against, right? That's why somebody like Francis Bacon, who remember was a lawyer by training, right? The law is really the place where we have, very well developed ideas of evidence. And evidence get brought into a trial, right? Basically to contribute some kind of weighting, some kind of either positive or negative value to the claims being made by the opponents in the case, right? So this evidence gets brought forward. It supports this guy, but it doesn't support this guy, right? I mean, that's usually how we think about evidence. The problem is that in this case, with the unidentified anomalous phenomena, you don't know what it means. You don't know what, there's no obvious explanation, right? It can't fit into the ordinary ways of explaining things. And of course, over the decades, the as it were, the sort of a base of this, the database has increased massively, right? And the Pentagon in Washington has been keeping track of all this. Now, what do you do with this, right? Now, the fact that it doesn't fit into laws of physics as it normally stands, um, is definitely an argument against it, right? I mean, it says, look, if these intelligent beings, if these were intelligent beings, we would figure out that they were there by some other means. This evidence would clear up, in a sense, right? We'd get some very decisive kind of thing. Well, not necessarily, of course. If these creatures have managed to come up with technologies that enable them to cross various spatial temporal dimensions, right? And as a result, don't have to travel at the great distances that we would have to travel from the sorts of places that we imagined them coming from if they exist, right? So in other words, all of those, thousands of light years that they would have to be coming from, they might be able to do it in a much, they might have found, right, a cosmic shortcut, basically, so it doesn't completely destroy their energy sources and their technologies. Who knows, right? Now, if that were true, and that's a very science fictional way of thinking about this, we would need new physics. We would need new physics. And so you might say, well, why not? Why not have new physics? Right? And so this is, so in other words, if you wanted to make a strong case for science fiction influencing science, as it has done in the past, there's no doubt about it, right? Then you can actually make a very strong proactive case in the case of extraterrestrials for actually trying to come up with a physics that can make sense of these unidentified anomalous phenomena on the assumption that they are extraterrestrials. In other words, if they're ETs, how did they do it? And so then you have to imagine a physics where you can cut through dimensions very quickly, right? Now, as it turns out in physics, right, we have these one of the trendy areas in the theoretical side of physics these days is string theory, which is trying to unify general relativity theory and quantum mechanics. And one of the things that it does in trying to do that is it proliferates numbers of dimensions, right? 8 dimensions, 24 dimensions, right? All kinds of numbers of dimensions, right? In order to effect this unification. Now, if we're willing to do that kind of thing to try to unify the established existing physical theories, why don't, if we're willing to postulate all these dimensions that we have no empirical evidence for, but we have, as it were, a mathematical need for them, right? Well, we could go further and say, oh, well, how would we have to relate these dimensions to each other in order for UAPs to be extraterrestrials? Right? In other words, we could make physics safe for UAPs. Now, this would not be the first time in the history of science where anomalous phenomena that cannot be understood by the established theories, have in fact kind of set the groundwork for reconceptualizing the field. Okay? And so, in fact, if you think about the relativity, the revolution that led to relativity theory in the early 20th century, right, it was about problems with the speed of light, right? Trying to get the speed of light, was it a constant or was it not a constant, right? Because people were operating with the assumption that there was some medium through which light was moving, which in some sense influenced the speed at which it could move. And Einstein, of course, comes along and says, no, you don't need a medium. You just need a constant speed of light, and everything works out. Right? And so the point is, though, this anomaly that had existed for a very long time, right? actually from the time of Newton, Newton could not figure out really how light worked. That was the one thing in his theory that really did not work out for him was how to explain light. And the revolutions in physics in the 20th century basically took these problems with the way light behaved as the centerpiece. So it's not out of the question, actually, to take very anomalous phenomena, strange phenomena, and rather than dismissing them out of hand, actually say, look, this points to something, it points to the limitations in our theoretical horizons, which need to be radically revised. Okay? Um, and I think I will sort of end the lecture at this point because I've been going on for about 50 minutes. I see, and I think there's a lot here for people to think about. In any case, thank you for listening.